Quadratic. Now, I am old school when it comes to solving factoring problems. I fall back to the most generic algorithmic way of doing these things.
That's the box method.
If you want to use the box method, by all means. I usually use the T-chart.
Oh, that one's.
I always fall back to that one because I can visualize what times what is negative 28. That adds together gets me negative 12. What are my factors of 28? They add together to get negative 12. When you see negative multiplier and a negative middle, do you know what the difference, what you will always have? You'll have, well, you always have two things. One of them is going to be positive, one's going to be negative, and the negative one is always going to be the larger of the two. Yes, sir?
The answer is x minus 14 and
X minus 14, x plus 2. Perfect. It's a negative 14 and a 2, which means your terms, remember we have terms, x minus 14 and then x plus 2. Because if you FOIL that out, ladies and gentlemen, you get x squared minus 12x minus 28. Now, if my terms are parentheses, we don't have an equal sign here, but let's say we did. What would be my zeros? 14 and negative 2. You're going to hear a lot of this talk about the differences between factors and zeros as we go on, especially as we get into polynomials. When we get into polynomials, we're going to have higher ordered equations, 8th degree polynomials, 7th degree polynomials that we'll be able to factor using a different method. It's called synthetic division. You're dividing by 0. Shh. It's an awesome way to do math. It's cool. No, what you're doing is you're taking out your coefficients. 1, negative 12, negative 28. What's the 0 here?
14.
It's a factor, which means your other term is x plus 2. That's what you're doing. Try again. Synthetic division is awesome. It's so easy. X squared plus 4x minus 21. Basically, again, what times what's 21 you add together to get 4?
7 and negative 3.
Yep, 7 and negative 3. Does it matter which one comes first?
Yes.
No.
No. Well, oh, I thought you meant like which is the sign. Like, yeah, it matters. It's a negative 7.
Oh yeah, that's what I'm getting at. Yeah, the terms themselves doesn't matter which one you put first, the plus 7 or the minus 3, because 2 times 3 is, you don't have to look at your chart, you probably know this one.
21.
6, and then 3 times 2 is 6. What property is that for $1 million?
Commutative.
I don't have $1 million, so I owe you one. Is that
You
the
owe
second
me-
million?
Yeah.
Yeah, you owe me $2 million now.
We should bet. You want to race on the times table? I'll go double or nothing.
No.
I'll go double or I'll go triple or nothing. Get this dub.
I've never even
I love
been
this.
I'll remember the
2x squared minus 2x minus 24.
Don't say the answer yet.
What do you do first?
Multiply like 2. There you go, or you could
It's
divide.
like
Or
the
you
greatest common factor.
First rule of factoring. Your first rule of factoring should always, always, always be, is there a GCF? If there is a GCF, please factor it out. It just makes your life easier. Because if you don't factor it if you factor it without taking the GCF, you might leave your answer in a not fully factored form. A lot of F's there. So now you fall into, bless you. What times what's negative 12? You add together to get negative 1. Done. Now this one, what would change if I did that? What would it be?
Why would be equal to 0?
I'm not worrying about this right here. I'm just saying, what if I said that? Well, what is that asking me to tell you then, or asking for an answer?
Solve for X.
Okay, what are your zeros?
4 and
Yeah, it's 4 and negative 3. when you're solving for zeros, when it says equals 0, does this GCF have any bearing upon the problem then? It doesn't, because you can divide both sides by 2 and it just goes away. So if it asks you to find the zeros, your answers would be 4 and -3. If it asks you to factor it, this would be your factor. Does that make sense? It's very subtle in the differences. Excuse me. Do we need to talk about special patterns? Do you remember the special patterns?
No, we don't
Alright.
talk about it.
Watch this. Let's say you have this. One of the things that you can ask yourself when you're dealing with special patterns is, first of all, these simple 3 questions. Number 1, is that a perfect square?
Yes.
Is that a perfect square?
Yes.
And last but not least, is that a subtraction symbol?
Yes.
Yes. So if you've answered yes to all 3 of those awesome questions, then your solution is?
X minus 7, X plus 7.
Okay. What if it was this? (4x² + 9). Number 1.
Factor.
Is 4x squared a perfect square?
Yes.
Is 9 a perfect square?
Yes.
Is that a subtraction symbol?
No.
Can I factor it?
Yes.
No. Not yet.
Would be,
No.
would be 2x plus 3. 2x plus 3 squared.
No. If you do 2x + 3 quantity squared,
Oh wait, no, you're right.
you get 4x² plus 6x times 2, so it's 12x plus 9. This we can't factor because you didn't answer yes to all 3 of those questions. You gotta have, it's called a difference of squares. This is called difference of squares. Difference of squares. Difference of squares allows you to do that. What if you had this? Let's see if we can figure this one out. Is x to the 4th a perfect square?
Yes.
Yeah. Is 16 a perfect square? So is that a subtraction symbol? Yes. So that means this could break down into x² minus 4, x² plus 4. Then what do you do?
Factor further. Is this
Factor it
still-
further. Yes.
is still-
You'll see that again. Is that a perfect square?
Yeah.
Is that a perfect square?
Yeah.
Is that subtraction? Your 2 terms are.
X minus 2X plus
And then here, I can't do anything about it because it's got a plus sign in between. And you're fully factored. Okay? You're fully factored. Now, by the end of this week, we will be able to solve this if I set it equal to 0. We'll be able to solve this problem once we get to the end of the week, after we talk about imaginary numbers. It's not that difficult, it's just weird. Right. The other pattern that they have in here is, I don't really spend a lot of time on pattern stuff because it's kind of like meh. Is when you have your junk squared. When you have junk squared, what does that mean?
Squaring each side.
Oh. Oh. Junk squared means what? Let me rephrase this. What does this mean? This means x times x, which means this means junk times junk. So what happens a lot of times is that you will see, I'll use this.
Is that a 5?
It is. It's like sticky in the zone for some reason. when you see junk squared, that means you have to multiply it out twice. It's not x squared plus 25. That is incorrect. You killed the puppy. That's what Seb says. I'm just following what he says. Don't kill puppies. Puppies are nice. Puppies are cute. Puppies are cuddly. Puppies don't want to die.
X squared minus 10 plus 25.
Hey, you see why I love this section. Remember, guys, junk squared means junk times junk. You get this special pattern that occurs. You have first term squared, last term squared. In the middle is the put them together and double it. Works every time. It's not necessary that you have to memorize the pattern itself when you are factoring that, because if you take x squared minus 10x plus 25, you're asking yourself, what times what is 25? You add together to get negative 10. Well, it's negative 5 and negative 5. So you could write it as either this is the factored form or that. Either one is fine by me. Okay? Either one is perfectly fine. Let me show you an example of that. So if you have x squared, let's see, we'll do plus 9x plus 80, no, it's 18, excuse me. Again, you don't necessarily have to recognize the fact that you have junk squared here. You could just go through the whole idea of what times what's 81 that you add together to get an 18. It's 9 and 9, right? And they'll both be positive because both these signs are positive, so it's just x plus 9, x plus 9. If you want to write it as x plus 9 quantity squared, it's fine. Either one is okay by me. Here's a good question. How many times does this problem touch the x-axis?
Twice. No.
Once.
Once, because they're the same intercept.
Exactly. This one is the type of question when you would factor it, when you graph it, 4, 5, 6, 7, 8, 9. It did that. Get that a little bigger so it looks like it's on there. All right, it touched it at one value. Whereas some of the other ones where you had negative 4 and 2, it touched it twice. You got intercepts twice. This one you have one intercept because it's just negative 9. Oh, let's do the one that everybody loves. Leading term coefficient not equal to 1. There's a method that I use that might be a little bit longer than what you guys would like, but it kind of forces you to do the problem correctly. I absolutely love setting these things up with what they call split middle term, or taking a GCF twice. I think most people call it split middle term. And the way I do it is, you probably remember, what times what is 30 that you add together to get negative 17? What times what is 30 you add together to get negative 17?
Negative 15,
Negative 15 and negative 2. Are you okay with that?
I know.
because I did the diagram problem and Mr. Juggins showed us.
So when we do this, we call it split middle term, factor by grouping. There's a bunch of different ways of doing this. I write it out as 3x squared minus 15x minus 2x plus 10. And now I'm going to take GCF twice. Okay? First thing I do is throw parentheses around these two. And I ask, what's the GCF of 3x squared and 15x?
3x.
Very good. I can factor out a 3x, and I'm left with x minus 5. We okay with that?
3x minus 2.
Now, the second part, since it's got a minus 2x plus 10, my object is to take the negative out. I'm going to take the negative out. And what's the GCF of a 2 and a 10? you always want to take this negative out, because when you factor out a negative out of the positive, it becomes negative. Because you always want these two terms to be the same. If those two terms are the same, what do you think we're going to do? We're just going to write it down. Just write one of them down. And then what are you left with? 3x minus 2. Factored via grouping. Split middle term. I know there are shorter ways if you want to use that box method or whatever. I know there are many different ways of doing this. I have always found that this method is one of those algorithmic ways that it will always work if you continue the same process each time. You don't have to mess around with anything. Yes, ma'am?
Wait, since x minus 5 is there twice, you wouldn't square it?
No, because what happens is, what do both of these terms have in common? Right here we have a 3x times the quantity x minus 5. Here we have a negative 2 times the quantity x minus 5. What do these guys have in common? Nx minus 5. I factor it out.
Oh, okay.
Because what you're doing here is you're just looking for a GCF. And that's kind of all it is. By splitting this apart, you're taking GCFs like twice. It's just another way of setting them up. Okay. And then what would change if it did this? Yeah. You'd have to get your zeros. Here you'd get 5. And then here, if I solve for x, you would have to add 2 divided by 3. So it would be 2/3. Oops. Okay. Let's see if we can get one of those. Your textbooks will always tend to change the letters on you all the time. 98% of the time, 99% of the time, whenever I do a problem, I usually use X. So don't get mad if the problem starts with like a Y or a T or an R, and all of a sudden I write down X. It doesn't matter. If you want to just keep using X, it's not a big deal. I don't know why textbooks do that. It makes no sense. So in this case, I have 9y squared plus 24y plus 16, which means I'd have to go 9 times 16 and figure out what adds up to be 24. Or sometimes there's shortcuts that you might not even think of. Think about the special pattern. This is one of those cases that if you do look at special pattern things, especially if you recognize that you have perfect squares at the front and the back, kind of leads you to it. When you have a trinomial, which means you have 3 terms, if the first term is a perfect square and the last term is a perfect square, it's probably a junk squared problem. Is 9y squared a perfect square? Is 16 a perfect square? Okay. So what's the square root of 9y squared? It's 3y. What's the square root of 16? What's 3 times 4? Double it. What do you get? So that means your answer is that's the special pattern. Whenever you see perfect squares on the tails, if it's 2 terms in subtraction, it's plus minus. If you have perfect squares on the tails and it's plus plus or it's minus plus, it's probably junk squared. Okay. It's a little shortcut on that. Let's say you had this equal to 0. How many zeros do you have to write out? You just have to write out 1. If you wrote them both out, is it the end of the world? No. You just have to write it down once. Because how many times does it touch the x-axis? Once. That's it. Is it up like a cup or down like a frown? Maximum or minimum? Good, good. You remembered things. So proud. And if you're not picking a lot of the squares up real fast, it comes with time. It's been a while since you guys have factored. You probably didn't do much factoring at all last year. I think in geometry, there's maybe, you could probably count the number of times you had to factor on both hands. I know there's a couple of them in the circle unit, when you had the outside times the whole, you have the foil, you might get some factors here or there, but for the most part, you haven't factored in a year. So just a little getting used to it, you'll be all right. Oh yeah, and you do a lot of it, and we do the factoring here as well. And Like I said, we do this, we solve the equations, we go through, there's some shortcut stuff we can do as well that I'll show you tomorrow and whatnot. So, I think with this unit, I did this last year, it worked out really well also. When we start talking about like the factoring, and we start talking about solving the equations, and we start talking about imaginary numbers and completing the square and all that kind of stuff, there's, in each one of these specific units, there's gonna be a ton of different word problems as well. What I did last year, and it worked out really well, is that I held off on the word problem stuff until we got to the very end of the unit. And then we spent like 3 days going over, or not 3 days, about 2 days going over the different style word problems you have with quadratics. When do you utilize the calculator? When do you want to utilize by hand? How do you recognize what one to use? And is there an easy way to figure that out? And I think by holding off to the end of doing that, it worked out really well. So I'm going to try and do that again this year with you guys also, if you're okay with that. Like do them all at once. Yay, enthusiasm. All right, what do you get?
2x minus 5. Oh,
2x plus 5 squared?
what's wrong?
And then 2x. I thought someone said 2x. Yeah, it's got to be, it's plus minus because it's, all three of the questions are yes. All right.
If it was 4x squared plus 25, it would just be 2x plus 5 squared, right? No, it wouldn't be.
If it was this, what would you say for your answer?
No.
No. Not factorable. It's not factorable if we did that. Okay. And it just takes a little bit of time getting used to that again. Is it possible you have a trinomial that's not factorable? Yeah. It's great. And I know which question you guys are going to have on your homework right off the bat. Hey, look at this pattern.
7 subhead.
Right. Is this a perfect square?
Yeah.
Is this a perfect square? Are these three terms? Are the signs alternating? So that means it's going to be a minus in between. What's the square root here?
7. R.
And 1, because what's 7 times 1?
7.
Double it. That's how it works. Just recognize
What
the
if you
pattern.
doubled it and it wasn't the middle term?
Then it's not right.
Oh, you want us to double check?
Yeah, because what I'm doing here is the special pattern. The pattern itself is that when you have a plus b quantity squared, you will always get a squared, a b squared, and then the middle it's always going to be 2 times ab. And if it was an a squared minus, an a minus b quantity squared, it's the same pattern, but it's first one squared, the last one squared, and this one will always be plus because what's a negative times a negative? Positive, and then the middle will be twice the 2 with subtraction. It's just a shortcut thing. I don't normally ever just list out those patterns because I want you guys always thinking about patterns. Like, oh, is this specifically? But if you recognize, oh, first term is a perfect square. It's 3 terms. Let's check it real quick. That's kind of what I want you guys to be able to do. I have any more than that. Oh no, I have to solve equations. What do you do when you are done? Cry? I hope you don't cry. Maybe someone will give you a hug. Give the poor guy a hug. He's sad. He thought he was going to die today. I'm an idiot sometimes. Obviously, right off the bat, this is not falling into a pattern because 3, last time I checked, is not a perfect square, nor is 5. So what's 3 times 5? 15. So we ask, what times what's positive 15 do you have together to get negative 8? Negative 3, negative 5, very good. So when you write this out, we have 3x squared minus 3x minus 5x plus 5. Does it matter which one you put where, the 3x and the 5x? It doesn't matter. It doesn't matter at all. You will get the same result whether you put it the 3x first or the 5x first. To be honest with you, if I ever have alternating signs, if I have a minus and a plus, I tend to put the -1 first because I'll be less likely to screw up factoring out a negative later on. It's just how I roll. And then I just do my GCFs twice. What's a GCF? A 3x squared and a 3x? 3x. I have an x minus 1. Now I need to make this negative 5x plus 5 look exactly like an x minus 1. So what do they have in common? Take out the negative. And now since these two are the same, we can factor them out. And you're at 3x minus 5. And what are your zeros? Yes, sir.
What is?
I got, since it's negative 5x plus 5, so wouldn't you just take out 5? Because
But here's the thing. If I take out just the 5, I'd be left with a negative. If I take out a 5 here, I'd be left with negative x. Oops. I'd be left with negative x plus 1. I want it to be x minus 1. So that's why whenever I have this negative here, I always take it out, which forces me to change that sign. That's why I do that. Yes, ma'am.
Would it be possible to get a trinomial and then like do this, but then like when you factor it out, like those don't match?
Yeah, it's possible. That just means it's a not factorable trinomial.
Okay.
So you should be able, if you're looking for zeros, I mean, you should be able to do that, and I'll show you guys some little other trick things here and there. But yeah, your two zeros would be at 1 and 5/3. Okay. Not 3/5, 5/3. Add 5 divided by 3. Let me give you a couple of these before we run out of time here. This is what, 5/2? So this is, again, this is in the old book. So it's that tab that says old book. Let's see. I think I did it this time. I think I went 24 to 88 by 4s.
What page?
So it's the section 5.2. I already have the tab up. And I believe if you go by 4s, it's not bad. So it's 24, 28, 32, 36, 40, 44, 48, 52. I'm losing count, 56, 60, and then another, what? 6? So it's like 16. It's not, it looks like it's a lot, but it's like 16 problems. And
That's a lot.
by 4s. So you're just going by 4s, yeah.
That's a lot.
It's not. Okay.
What page is this?
It's in that 5.2 tab on, it's the old book stuff, so it's page 261 in the old book. Now, like I said before, on the website, I have the, once I find it. Oops. It's on the tab that says Old Algebra 2 book. Click that one, and I already have the 5.2 open on there. I'm just going to put the problem numbers down next to it. Yeah, help yourself. They're on my desk. Just sign one out, okay? I made my own. It was quicker than having to write out. So I put it right here for you guys. All I have to do is click on the tab, and it should pop out. I know last week somebody was saying that none of them were opening, but I reset all the standards on them. I don't know why Google defaults everything. It defaults everything to view. Like I'm the only one that can view instead of share setting. So there's nothing I can change about that except hope that I don't forget to change it. So let's see here. Let me edit this. Do. So let's see. We're doing what numbers? What page did I say that was? It's page 260 or something like that? Was it 252? Is that what?
It's 260.
260?
It starts on 260.
Okay. Thank you. So today's Monday, right? Yeah. All right, so put this on the calendar. So this is 5.2.
Murphy, can I get one back?
They're on the thing. Just sign one out for me, please. If they give you guys the business because they're not the official ones, tell them that. Well, then make them for me. Just don't have them yet.